Hello everyone, you are welcome to my YouTube channel. In today's video, we'll handle exercises with functions. So here we want to solve some problems to demonstrate the power of functions in Python and also the application of functions in our day-to-day activities. So the first problem here has to do with a compound interest rate, or what we often refer to as the annuity problem. So here we have a specified amount, initial amount that is invested to grow at a given interest rate P for n number of years. So we are asked to make a program to compute how much $100,000 have grown to after 3 years with 5% interest rate. So the first thing we do here is to open our IDE, open a new script file and call it interest rate. Okay. And then we define our function interest rate that takes a, p, and n, passing our string, it computes the amount in the bank, define our arguments, and then enter the future amount equals a times 1 plus p over 100, double asterisk n raised to power n, and then return future amount. Around this cell, I have the function in my namespace. Then I can then call amount equals interest rate and then pass in the values a equals 1,000, p equals 5, n equals 3. You can see that here, even though I've defined my input arguments as what as positional arguments, I've called them as what as keyword arguments, which is proper. So it gives some readability or makes your code a little bit more readable and clearer to the user. So I can now print amount in a bank with my string amount to two significant figures. You can actually print it to the nearest whole number. It doesn't really matter. Let's print it to one significant figures. If we run this cell, it tells us that the amount in bank is $1,157.06. The next problem here is that we're given a quadratic equation ax squared plus bx plus c equals 0, and they have two roots. In other words, if you solve this problem, you have two roots to that equation, which is x1 and x2, as described by this expression here. B squared minus 4ac that we have inside the square root common to x1 and x2 is often referred to as the discriminant. So we are required to write a program that solves the given equation if A is 2, B is 1, and C is 2. So let's look at the solution. Open another file and then call it quadratic roots. Then we import maths and define the function quadratic root passing a, b, c. My one-liner dot string follows, and then right inside there, I'll do some abstraction here. Take out b squared minus 4ac and call that d, the discriminant. Okay, and I can have x1 equals minus b plus math to square root. Okay, I'll call the square root function in from the math module of d and then divide by 2a. Likewise, x2 minus b minus, and then I return x1 and x2. If we run this, what do we have? It gives us, you have our quadratic root already in our namespace. Then the problem says when a is what? When a is 2, let me you call it as keyword argument, a is 2, make it a little bit more clearer, and c equals 2, right? Calling this as keyword argument means that you can, the position doesn't matter. I can call B before A or C before A, but in as much as it has been assigned the respective keyword, the function on Python understands how to order it. So if we run this, well, what do we have? We have an error. Most times in Python, when you hit an error like this, you have it, take a seat and relax and look at what's happening here. Value error, trace back most recent last call. We look through what did we do wrong. It's pointing to line 3 for the function. But we go down, is point, you can see this arrow pointing to line 6. So there's something happening here. And so let's see, it's a math error, math domain error. Okay. Yeah, whenever you hit something like this, first of all, try to debug the code internally. So I'll come down here and say, let me print D. Okay, let's print D. Let's say the discriminant. Discriminant, discriminant equals, I want to print D. Let's see what it gives to us. Run the function again, and then, of course, to have it in the namespace. And now I call x1, x2. Wow, discriminant is negative. The math error still persists. So it means that math library cannot, math.sqrt cannot handle when you have a negative square root. Okay, so how do we debug this? There are so many ways of doing it. Okay, one way is to use another module that takes care of the negative square root. The second method is to use a condition here and manually take care of the negative root. Okay, how do you manually do that? You pass in an if condition. If d is less than 0, okay, return. Let me just demonstrate that. If d, let's demonstrate that second method. If d is less than 0, let's see, what should we return? If d is less than 0, so save time, we should return, multiply this by minus. We'll just multiply the value of d by minus to make it positive, right? Okay, and then we can do something interesting here as well. We can come here and use j times, okay, j times that, because there's already a complex number there. So this is, and then use j times, okay. Else, if it is not less than 0, what do we have? Else we should have return the way it should be. It means d is what? Else it means d is positive. This is one way of doing it. We'll run this again, and this time around we'll call the function. What is to use is cmath, okay, cmath, and then we call cmath.sqrt. It automatically takes care of that negative root for us. So we run this, and if you call b equals 1 and 2, we see it's already gone, no error. So we can print, I can print, use my f string and say x1 equals print x1. I can use the one liner, so one liner, next line, that what it means, x2 equals, I call my x2. So we run this again, it gives us what x1 is and what x2 is. So you can see 0.5 and blah, 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 and j, and then j. Likewise, if I change this value to 4 and run again, you will see what happens. Returns again another result. So each time you change the value of this 24, change alter the value of a. What this means is that 0 just means the complex part is 0, so you can ignore it. All right. So that's how you can code solve this problem. Now, the next I want to look at is using the range function, okay, to loop through a sequence of integers, right? And the range begins from start, stop, and step, okay, all put into a tuple. And mind you, it does not include the upper limit of the stop, okay, among the list items. So if you want the upper limit of that stop, you need to add +1. Now, let's try to use that to implement this expression q equals the summation of 1 over n squared, starting from I equals 1 until what? Until n. So how do we do that? Because we want to sum this, one way of doing it is that we can use a list comprehension, or first we can accumulate this value. So we initialize the sum to be 0, s to be 0, and then we loop through a range of, okay, 1 comma here, let's assume that our n is 10, so but we'll loop through a range of 11 with a step of 1, right? And then we return an accumulated sum of 1 divided by I squared. In other words, the inverse of I squared. If we run this cell and then we can print x, we have the sum. Likewise, you can remove the step because the step itself by default is 1. We run again, it returns same result. Okay, that's one way of doing it. A second way of doing it here is to use a list comprehension, right? We use a list comprehension. So we'll say S equals 1 divided by j squared for j in range, okay, with step, and then we'll print S. Now, this will return for us a list, after which we can sum every item in that list. If we run this cell, returns a list. We can see the first one is 0 until the last one. So we can then sum this. How do we sum this? We simply just import and import NumPy library as np, and so we can then return the value of np.sum, and we pass in s to it. If we run this, it gives us the sum of those numbers. You can as well also use the math library, and then you can sum it up. That's one way of doing it. You can as well call np.sum on directly on the list comprehension. Here we'll come and call np.sum because s is np.sum, so that when you print s, what do we have? It returns the same result. Let's look at computing sum using a Python function to do that. Here we have computed sum without using a function. Let's see how we can use a Python function to do that. And this will be the last example I will look at in this video. So I have L, capital letter L, a function that returns, you can see it is parameterized by X and and N. So we are summing from 1 to N. 1 divided by I multiplied by the inverse of 1 plus I, or raised to power what? I, right? So we'll define this function as L, takes in X and what? And N, right? Takes in X and N. Then we call it what now? We simply call, initialize the sum S, okay? The accumulator to be 0. Then we do for I in range 1 until n plus 1. We want to sum from 1 until n, and we want n to be inclusive, but in Python, the range function does not include the stop value, which is the upper limit, so we add 1 to it. What should we do? We should accumulate 1 over I multiplied by, it's not x here, it is 1 by 1 divided by 1 plus x, or raised by I. And then we should return s. If we run this, we have our function, and then we can call our function. It's returning a value, so we can print the return value. We want to print, let's choose a value for x. We choose x equals 5, and n should be, preferably, let's sum to 20. To run this cell, what does it give us? It gives us the output value of n, which is the sum of that. You can see there are very many of these expressions in different disciplines, and you can easily abstract any mathematical expression as functions in Python. In the same vein, if you don't want to modify this function as well, there is something we can do again on this function. Maybe we want to do some other calculation, want to do some other evaluation, and then we don't want to modify the function directly. What you do is that you recall the knowledge of closures, okay, and decorators that we learned, or you simply need to write a closure and then decorate this function to do that. So with closures and decorator, you can easily modify the function without actually going into to modify the function itself. With this, you are able to maintain some backward compatibility without breaking the code. We have come to the end of this video. Please like this video, share this video, and if you are watching and you have not subscribed to my YouTube channel, please subscribe to my YouTube channel to encourage me to push out more of this content. Please remember to click the notification bell to get notified of my new upload. I will see you in my next video. Bye.